All right, cool. All right, cool. So the last time we were working on the whack-a-mole, so we'll just continue off of that. Um, All right, cool.
Is there any code that I can?
Yeah, I'll are you on the Discord by any chance? You are? Okay. There's a GitHub.
I can pull from right?
Yeah, there's a GitHub. Let me make sure that I've updated. Be under documents. Don't judge me on my commit message. I totally forgot what the date was, so whatever. There you go. Okay. So in Discord, you should have the GitHub, so you can go ahead and clone it. It's a very small project right now. But just to recap, what we accomplished is when we have the little mole, when we click on it, it goes away, which is the beginning of our whack-a-mole, right? Okay. So the objective for today's meeting is to get the game manager to randomize the location of the mole, and then every time you click on it, right, it goes away, and then the game manager will wait a little bit and then randomize the location of the mole again, and we'll just keep that loop going basically forever for now, and then we'll add more game logic like keeping track of the scores and then adding a timer. Right, so if you ever played whack-a-mole, if you haven't, I put a link in the Discord on what that whack-a-mole looks like. So, and today we'll be deploying to device, to Android, so you guys can play around. And if you don't have an Android device, that's okay. We can use an emulator. So hopefully that doesn't take that long to set up.
And this is the Unity
3D, yeah. Yeah. Okay. Does anyone have any questions? No? All right, let's go. So we've already set up our game board. So that's how our game board looks like, right? So the little black holes represent the actual holes where the mole's going to hide. So let's make this a little bit bigger. All right, cool. Okay. And if we run this, we should still get the same result, where if I just tap on the little mole, we shouldn't get any more of that jitter because the plane is blocking the raycast from the camera screen to the mole, right? Now, there's going to be a problem, right? And that's if I click too quickly, the animation is going to try and trigger itself on itself again. So if I keep clicking on it, you can see how it has that little jitter, right? Basically what's happening is in the state machine, it's going to try and transition into itself, right? So there's a couple of ways we can fix that. And the main way we want to actually fix this is that when the mole actually gets clicked, we want to disable the collider. This way, the actual raycast will pass through the actual mole, okay? Because we're going to use an event system, so when the mole gets tapped, the game manager gets notified that the mole got tapped. If we just have it where it just ignores the animation using, because the animator controller has a way to say, do not allow transition to self. If we were to do that, and if we clicked it too many times, the game manager will think you hit the mole multiple times. And so we can get an issue where maybe the player gets too many points. So we don't want that. So let's first work on fixing the mole. So let's disable the game board so we just see the mole. And let's open up the mole script that we have, and we're going to begin modifying. Okay. Cool. Can everybody see that? All right, let me zoom out just a little bit. All right, cool. So we have this event called it's getting whacked, right? So one thing that we could do is we can just have the mole script actually have a reference to the collider that it has. That way we can disable it for a little bit and then re-enable it. Right? So let's go ahead and do that. And this is how we can create a reference. And the reason why it's public is so the inspector can serialize it, and so it gets exposed inside of the inspector. So if we go back and we look at our mole in the inspector, give it a moment to compile, we have this new field. Okay. Now, the actual collider exists on this game object that's nested, a child, called graphic. And we have this capsule collider. Now, my mole actually doesn't care what kind of collider it is. It could be a mesh collider, it could be a box collider, a sphere collider. I just called it collider. And because collider is the base class for all collider types. Okay? So, because it has, because this is the base class, if I just grab the graphic and just hover over, you can see that there's this little plus sign on my mouse saying, basically letting you know that this is OK. So if I just let go, we've now linked the mole script with the collider. Right? So now what we can do is this method, the last time we linked it up with the event trigger. So when the mole gets quote unquote whacked, we can actually say this.collider dot, right? And we can say enabled equals false. Right? So this will disable the collider when it gets whacked. And so let's see this in Unity. Click on the graphic. Okay. And look at this checkbox right here. Right? So I'm going to hit play. And then when I hit it, the checkbox gets unchecked. And if I keep trying to click on it, it doesn't work. Versus if I manually enable it, you can see that it's continuously getting whacked. Right? And that's what we don't want. We don't want that to happen. We just want it to get hit once, and that's it. Does that make sense? OK. Now, we need a way to re-enable the collider, right? So what we can do is we can create a method. And we can just call it, I don't know, reset state, I guess. And we can say this.collider.enabled equals true. OK. Now, who's going to call this reset state to re-enable the collider? Well, that'll be the game manager. Because once the game manager knows that, hey, this mole got whacked, right, the game manager can then, once it repositions it, it can say reset state. And then what we can actually do is, inside this reset state, we can have the mole appear. Right? So what should we do then? The other thing we can do is we can grab a reference to the animator component. And we can say set trigger. Just like that. So now, when the game manager is ready to show the mole, it can automatically say, hey, reset the state. So it enables the collider, and it does the show animation so the mole pops back up. Is this a good way of doing it? No, but we're not there yet. We're just trying to get it quick and dirty, and just to get something on the screen, and then we're going to use our software engineering skills and make this flow better. So don't judge the code yet. This is just to get something to show. Cool. All right. So our game manager originally just had a reference to a game object called mole, right? And as you remember before, when we hit the space bar, the game manager just moved the mole around, right? So if we enable the game board, if we hit space bar, as you can see, we had the mole just popping up in a random location and then hiding. You guys remember we did this, right? But that was me hitting the space bar. We don't want to do that. We want the game manager to control the flow of the game. That's why it's called the game manager. Okay. So let's move the mole below the game level. We'll move it to like -10. Doesn't really matter. And let's go back into the game manager, and let's change this game object reference to be the actual mole script, just like that. Okay. Now what we can do is we can set a timer. So the start function is a quote-unquote magic method. It's basically a method that will get called on all mono behaviors when the script is ready to be is getting loaded. So the execution order is there's an awake, enable, disable, and there's one called start, one called update, late update, and fixed update. So start will only get called once, only when the script first gets loaded, which is perfect. So this is going to give us the ability to set things up inside of our game manager. And one of the things we need to set up is to start this timer. So when we first launch the game, what we want to do is wait a little bit and then start the game. And in order for us to quote-unquote wait a little bit, Unity has a thing called coroutines that we can use. You can think of it as kind of like a thread, but it's not a thread. It's still working on the same thread, but it allows you to execute a little bit of code at a time. So that's perfect for what we want. And it's the IEnumerator. And we've done this before on the show mole, right? We had it show the mole. We had it wait for a little bit of time, and then we had it hide. So we're going to do that again. So we can call this something like the start game. Okay. And what's the first thing we want to do? Is we just want to wait a little bit. Or let's debug to the console. We can call it, we can just say get ready. We can say wait for seconds. We'll wait 2 seconds. Okay. And then we want to have the mole spawn in a random location. And because this method's going to be happening quite a bit, we want to maybe put this in its own method. We'll call it show mole or something like that. And the show mole will, I already have another one. Yeah, we can just remove all this stuff. In fact, we can just remove all this. So what we can do from here is we're going to have it randomize the location where the mole is going to pop up, and it's going to call reset on it. And we know that the collider will get enabled, and it will show itself. Right. So let's try that. So we're going to reset the state, and we need to move it. So we have all the location, all the little holes that we have reference to. So now we're just going to have to pick one of these at random. So we can say transform hole equals the actual holes. And the way we can get a random index, right, is using the random class that Unity offers. We can say random dot range, and this is you can pass in a range, right, the lowest number to the highest, but it's exclusive, so it doesn't have the top. So if you say 0 to 5, it won't include the 5, it'd be 0 to 4, right? So we want to have the range be 0, because this is an array. So we're going to index it from 0 to whatever the length is. Right? So that'll give us a random hole. And then we're just going to say this dot mole we're going to move the transform of the mole to where the hole is at. That's basically it. Okay. So in start game, after we wait a little bit of time, we're going to go ahead and say show mole. Okay. Now how do we kick this off? To kick off a coroutine, you just say start coroutine, and then pass in the coroutine that you want, which is start game, just like that. Okay, and this will kick it off. So let's go back to Unity, and let's see what happens. So first, you're going to see that because we changed the type of the mole from game object to the mole script, we lost the reference. So we need to drag it back in here, just like that, drag and drop, and then let's hit play. And let's look at the console right here. So it says get ready, and then after a while, the mole pops up, and it stays there. And isn't that the whole point of the game, right? And then you whack it, and it goes away. And it just got whacked. Right, so we're almost there, right? Little by little, bit by bit, right? So we need a way for the game manager to know when the mole got whacked. That way the game manager can then proceed to, well, 1, give you points, and then 2, go to the next part in the game loop, which is let's wait a little bit, and then we need to move the mole again, and then show it, right? So how can we do this? Well, for 1, we can do an event, and we can actually have the mole have an event. And the game manager can subscribe to the mole and say, let me know when you get whacked. That way the game manager knows, hey, this mole got whacked. And the game manager can react to that. So let's try it that way. So how do you do that? You can say public event, right? It's an event. It's going to be a type of action. We're pulling this from system.action. The system is the namespace for the standard .NET. And we're going to call this on got whacked. Okay, just like that. Okay. So we need to know, or we need the mole to raise this event. Okay. So when the mole gets whacked, we're just going to say if anybody is listening to this event. So if it's not null, so if it's null, that means nobody's listening, nobody's subscribed. If it's not null, that means people are listening, people are subscribed, and let's let them know, hey, this this particular event that you're listening to, it's about to get fired, right? I'm gonna fire it. So this dot on got whacked. You can say dot invoke, right? So that's a little bit more legible, just saying that it got invoked. Or you can just call this like a function like that by using the parentheses. Either or works. And if you don't want to actually use this whole if not null, whatever, a shortcut, so we can say like that. Oops, how do you do this on Windows? Dang. I don't know how to do this on Windows. Let's see. Dang. Does anybody know how to highlight and then add, what's it called? The whole block section, add comments, forward slashes?
It's command forward slash on Mac OS.
On Mac, but on Windows.
Control forward slash.
Huh, it's not working.
To be fair, I use different IDs.
Yeah. Control Shift V. Control Shift. No, that's not one. Anyway, we'll delete it, whatever. The alternative is you can say this dot on got whacked. So C# has this thing where if you had a question mark, it's the same way as saying if it's not null, go ahead and do the following. So you don't need to have an if statement. So this is less code, does the same thing. Okay, so let's go with that. Now in the game manager, when the game starts, when it says start, so right before we actually quote unquote kick off the game, we're going to say this dot mole dot, and you can see there's this on got whacked now. So if I call it like this, if I hit space, it's going to want an action. So the way you subscribe to events in C# is use plus equals. Right? If it says, it's right here, it's saying, hey, you want me to create a template for you? If you hit tab, it'll automatically create one. And it's telling you what is the type, right? So just the naming convention here is what is the actual class name, in this case called mole, and then what's the actual event you're subscribing to, on got whacked. You can call it whatever you want, right? But if you hit tab, this is going to generate a method stub for you. Okay, cool. So what do we need to do now? Well, once the mole gets whacked, you want to get some points, right? So let's let the game manager for now just debug to the console saying you got like 5 points. Right, just like that. So right now, very, very simple. Got 5 points or something like that. Now the game manager knows, hey, this mole is now hiding. We need to move it. So what we can do, again, every time you want to wait a little bit, maybe try and use a coroutine, right? So we're going to make another one. We'll just call this reset mole. So we're going to say we want to wait a little bit. We should wait maybe half a second. And we're going to call this dot show mole. So inside of our on got whacked, we'll kick this off. just like that. So now, let's see what happens. So let's clear the console. And then, so we're going to hit play. And there's the mole. So it says get ready, right? And here's the mole. I click on it. Bam, got whacked. Plus 5 points, and it waited a little bit, and then it reset it. And there's our basic game of whack-a-mole, right? That's it. Plus 5 points, right? So this is the obviously the very baseline of what this game is. And you can see every time I'm whacking it, it pops back up because the game's called, whack-a-mole. And if you try and do it really, really fast, it only happens once, right? Because remember, as soon as it gets tapped on, we're disabling the collider, so it can't have multiple events get fired on it. See that? So that's exciting. And it's just going to keep going and going and going forever. There's no way to stop it, right? We haven't added any logic to that. And I think the original game of whack-a-mole, I think you have like 30 seconds, and it's basically how many points you can get within those 30 seconds. So obviously, the faster you are, the more points you're going to get within those 30 seconds. Okay? Does that make sense? Does everybody have any questions? Okay. Now, because we're using the event trigger, there's none of this on mouse crap, right? This is very abstract. We're utilizing Unity's event system and the input module, so we don't actually care if it's a mouse or if it's like your finger on the screen. So knowing that, let's try and build it to the phone, an Android phone, and let's test it out. Let's see how good we did. So if you don't have an Android phone, I have an Android phone. If anybody doesn't have, yeah. So I have two. They're probably dead or really low power. I charged them a little bit this morning. So let's see. Okay. And they're both dead. Oh, this one's turning on. Okay. So does anybody need an Android phone? I have two. You just need to plug it in and wait a little bit for it to charge and turn on. Does anybody need one? No? No? OK. Just me? All right, cool. All right. OK. So I plugged in my Android phone. Now, the next thing we need to do is ensure that ADB is connected to your environment variables, specifically if you're on Windows. So this is a fresh install of basically everything. So any errors that are going to pop up right now or anything that's missing, chances are you're going to run into this as well. And that's perfect because I did this on purpose. I want if there's an error pop up, I'm going to fix it, and you can see how I fixed it. So the first thing we do, open up command prompt, right? And just type in ADB. And look at that, it's not recognized. I kind of thought that would happen. So you need to have Android Studio installed, okay? And the reason why is because you need the Android SDK stuff. So obviously Windows has no idea what ADB is. ADB is a little shell program, right? Well, not really a shell program, but a little program that you can feed it commands, and it's an interface. It's called Android Debug Bridge, and it allows you to interface with your phone that's connected via USB. And that comes with the Android SDK under Platform Tools. So we need to link that path, wherever our SDK is, to Windows. Now, to find where Android Studio placed it, we need to open up Android Studio. OK, I got to find it manually. It's just called Studio. Okay, great. What? No. Oh, yeah, it's an icon. Okay. So it's the Studio 64. You know it's this one because this is a type. It says right here application. So there you go. So we're opening up Android Studio. And then you can go to configure. So you don't need to actually open up a project. You can just go to configure. And then you go to the SDK manager. And it'll actually tell you where actually place the SDK. So as you can see for me, my Android Studio location is under username, app data, local, Android, and SDK. So let's go ahead and copy this, open up our File Explorer, and then paste it, go to it, and you're going to see there's this platform tools. If we go in here, you'll find the ADB. See, it's an application, it's an executable. If we run this, well, it's not really, nothing's really going to happen, right? But we can, I think Windows allows this. You can actually drag this here. Yes. And if I hit enter, bam, I get exactly what I wanted. The problem is I don't want to have to drag it, right? So how do I fix this? I need to add this location to my environment variable. So I'm gonna copy this. Go to Control Panel, System, go to Advanced System Settings, and why is everything grayed out? There we go. It was all grayed out for some reason. I don't know. I'm recording and I'm streaming. Jesus, my computer's on fire right now. Okay, go to Path, go to Edit. Is it here? No, we want this one. Okay, well, Windows 10 is different now. Okay, so I'll just hit Edit. And all right, so we'll just hit New, paste it in there. I'm not a Windows 10 user, so hopefully that works. Hit OK. Hit OK. Hit OK. And we're going to close command prompt, and then we're going to open it up again. And then hopefully, if we type in ADB, we get all that text. And we do, so we're good. Now, why do I need that? CLS. Because now I can type in ADB devices, and I can see all the Android devices that are connected to my computer. Now, this needs to start a service, right? And there you go. It says right there that has this computer, this is the serial number to my device, and it says unauthorized. So I plugged it in my Android phone. You obviously can't see this on the screen. So I have, if you go to the settings and then all the way down to about, and if you go to, I think it's the build information. If you tap it a bunch of times, you become a developer. You can Google it for your phone, and enable developer options, and make sure you enable USB debugging. Once you have that, when you unlock your phone, it's going to ask you. You have this image that's basically saying allow USB debugging, and it's going to say the computer's RSA key fingerprint is blah, and you can say allow this computer always. Or whatever, or just allow once. So this is my computer, so I'm just going to say allow always from this computer. And I'll just hit allow. So now if I hit the up arrow, and instead of saying unauthorized, it just says device now. Okay. So that's cool. Next, you need to know what type of CPU or the architecture of the phone is. So I have an Essential Phone PH1, and so I know mine's using ARM7. So the reason why the last time I was trying to do a build it didn't work is because I think I put x86. Should have put ARM7. So to change your CPU, you go to Edit, Build Settings, Player Settings, and under the Other Settings, you can actually check what kind of build you want to do. So the architecture here is ARM7. So I'm going to hit Control B, and it's going to just start building. And if we did this correctly, it should just work. Quote Todd Howard, right? Does anybody have any questions? Is anybody running into any issues? No? All right. Can you hear my fans? We're taking off. Oh, jeez. Well, I'm building a rig, and it's a Node 202, so I'll be able to carry it around. So when I come, it'll just be this gigantic, like, super powerful, you know?
Yeah, they're about Xbox size.
Yeah, a little bit bigger, you know? And it's perfect because it's very low profile.
It's
So.
bigger than the 1X, maybe not bigger than Skype.
It'll blow it out of the water, though, for sure. So I can't wait. And then it'll do these builds and like, it's like easy peasy. Yeah. That's why, like, if you're going to be doing development, right, get something that has a really powerful CPU, because that's all computation. All right, cool. So for you guys, if you guys want to see, right, let me turn the brightness up here. I'll put screenshots of this. So there it is. Now, right, so pretty good, right? So now if I just tap on it, because we're using in this abstract layer of this pointer instead of like mouse or finger taps, right? If I tap on it, it should just work. So there you go, boom. See? And it's just random. Right? And it'll just keep going, right?
That actually is legitimately a fun part of building a leaderboard, is that you do get to have the high score.
So that's pretty good, right? So look, it works just like that. And if we were to build to iOS, I'm on Windows right now, even though I'm on my Mac. But if I was on Mac, I can build this to iOS, and it'd basically be the same process. It would work, right? It's not going to build it directly to the device. It would build an Xcode project. You got to mess around with the provisioning profiles. But yeah, so the next time I'll actually do on how to actually build to your iOS device if you have one, or to your iPad. I have my iPad, so I'll do it on both. But yeah, so obviously for those that are watching on YouTube, you can't see what I'm doing, but I will post screenshots. And so yeah, so we know it works, right? So isn't that cool? So it's working. So that's cool, exciting. So I'm gonna kill this real quick. All right. So what's the next step now? Obviously, there's plenty to do. For one, I don't like the randomizing. Sometimes it happens on the same one twice. You would probably want to have a while loop to be like, okay, what was the previous hole I was at? And continue randomizing, but ensure that you're never on the same hole twice, right? Actually, let's just do that. Because why not, you know? So where are we actually picking the, right here, okay? So, because that right now, it pops up in the same location twice, right? And that can be kind of like, you saw that when we were running it, sometimes it was in the same location like 3 times. So that's kind of like, don't want that right? So what we can do is we can say private int last whole index or something like that. Start off at 0 or something like that. And then we're going to say int next is equal to random.range 0 to the holes.length. So pick a random range. Because we're using an array, right, having this exclusive is perfect, right, because it's going to be 0 to 1 less than the length, which is perfect. Okay, so what do we do now? We're going to say while next does not equal this dot last whole index, or while index, if it's the same one, right, we're going to say next equals random.range, and basically keep finding one. So it's like, don't be in the same place twice or more than once. Okay? So we just keep looping until a new location is selected. Again, still random, but we want to be in a different location every time. So we can update this to say next, the next location. And we need to just make sure we update the last whole index to next. And we should probably set this to -1 for the beginning, right? Because null, in the first time it selects, it's going to be negative. You can never have a negative index, right? So by setting it to -1, we know that the first time it ever tries, it's good enough, right? After that, we need to just check. So let's try this again. Let it compile. So hopefully we don't get a stuck or anything like that. Here we go. Bam. And it's always going to be in a different location. That's much better gameplay, right? It's always in a different location. Now, I don't really know where it's going to go, right? I don't ever anticipate that it's ever going to be in the same location twice. So this is looking more and more like a real game of whack-a-mole. Does that make sense? Okay. Cool. Does anybody have any questions about that? No? Does everybody have that working on theirs? No? What's the issue you're having?
Well,
You don't have the project?
yeah, I didn't know you uploaded the video last night.
Oh, yeah. Well, what you can do is on the Discord, there's a GitHub link to this game. You can just pull. Yeah, you can just pull it. Oh, yeah. Yeah, we have a GitHub that I pay for, so please use it. Yeah, so you can just go ahead and pull or clone it first. You know how to clone a Git project?
Yes.
All right. Well, if not, you have the master Corbin right there. So our special guest, very, very special. Very special.
Oh, okay. I'm special in something.
Cool. Let me move this. Okay. Cool. So we're almost there, right? We're almost there. So let's take a look at, in Discord, I had linked a here. Did everybody see this video of the whack-a-mole? No? Let's take a look at it. This is a real-world example. We're trying to simulate this, right? So let's just take a look at it.
Go to the one on the left, huh? There you go. Okay.
Let's play whack-a-mole.
You can see the idea. And in fact, in this game, there's multiple modes. Ours only has one. So if you want to have multiple modes, I'll leave that as an exercise for you. actually not that bad. In fact, maybe we might. As you can see from the game here, or from the video, you know, they just pop up, you hit them, you're getting points. And I think for each ball you're hitting, as I'm looking at the scoreboard, it's 10 points. But I don't see if there's a timer. Maybe there's a timer in tournament, but I don't see a timer.
Wow. Let's see if you can do it even faster next time.
And you lose a life, and then okay, that maybe that's it. I don't know. That's a little freaky right there. Okay. All right. So what way do you guys want to do this? Do you guys want to have it where it's after X amount of time, or just have a timer and then you know, however many moles you can whack in like 30 seconds or something like that? Should we do that? Timer? All right.
So wouldn't we want them to drop? They don't touch them down?
Right. So we actually do want to do that. So how do we do that? We need to have some way to control that flow, right? And so I'm thinking, because there's a timer involved, I really like to use coroutines, right? Because you can also stop them. You can start one and then stop it, basically kill it ahead of time. So we can actually do that. Exactly how you said, oh, we need to also have them go away after a certain amount of time. So let's try and get that working first, okay? So inside of our game manager, after we reset the mole, we need to have a way to have the mole hide itself after a certain period of time, right? So let's do that. We'll call this monitor mole or something like that. So we're going to monitor her. Okay. So after what? How long should we wait? Like half a second or something like that? Or 2 seconds? 2 seconds? Okay. Okay. So after 2 seconds, we're going to need to tell the mole, hey, I need you to hide yourself. But also, while you're hiding yourself, I need you to also disable your collider. Because what if it's animating, it's going down, the collider's still enabled, and you whack it? Should we still allow that? Right, because we're the developers, right? So we can do whatever we want. Is that something that we want to allow, where after 2 seconds, we're going to tell the mole, hey, hide yourself, but in the meantime, the collider's still available, so you can actually touch on it, and technically you would still get points for it, right? Should we allow that, yay or nay? Nay?
Down, don't want to get points, right? The problem with that too is that we have to be careful that it wouldn't reset the animation, and then
Aha.
as it's going down, it would go back up and go back down again.
But remember, in the animator controller, we can actually tell it, do not transition to yourself. So in that case, if we say hide and it's already hiding, it'll just ignore the hide request. So we can get around the whole animation artifact. We can get around that. But the thing is, the logic. Do you want to get points? Because you have a timer. It's already past 2 seconds. It's gonna hide. I remember like playing like Legend of Zelda and stuff, and like when you're in like the little when you're doing the little mini games, when the period of time after it was like over, if you try and hit it, it wouldn't do anything. Maybe we do the same thing, or maybe we don't. What should we do? What's the consensus? Give them points or no? Give them points? Okay, cool. So we need a way to tell the mole to just hide, right, to just hide, right? So we want a way to just say this dot mul dot, we want to just say hide, right? Or something like that, or show, right? We can say show and then true or false. That'd be the same as hiding, show, false, or something like that. So we want to be able to do something like this. Because you guys are saying, don't disable the collider. That's what you guys are saying. Okay, that's totally fine. Okay. So let's go to the mul and let's make this method. So we'll pass in a variable called, actually show there. But let's pass another parameter. So we can say do disable collider. So if we pass in true, we'll also disable the collider, right? If we pass in false, we'll say don't disable the collider. That way later on, if you guys say, you know what, in fact, when they're hiding, we should not give them points, well, you can just switch the true to, or the false to true, and we disable the collider. That way it saves us some need to refactor code. We can just switch one thing, and then we're good. Cool, so we're going to say if show, okay, if show, right? We need the animator, right? So we're going to say animator. Again, it should not be done this way, but let's do it this way anyway. Is equal to this dot get component. There you go. We're going to say anim dot set trigger show, like that. Okay. Else anim dot set trigger hide, and then we can say if do disable collider or you might not have to do that. We can just say this dot collider dot enable equals do disable collider. We'll do the opposite of that. Because if collider enable is set to true, it's enabled. If we say do disable collider as in true, we need to do the opposite. Okay, so we're using reverse logic here, whatever. Cool, so let's go to the game manager. And we can say false and then false. And if you look at this method just off the top, if you're a developer looking at somebody's code and you see this show false false, at a glance you're just like, what? What does this mean? In C#, and I think other languages too, you can actually do something like this. You can actually call what the variable name is actually called inside the method. Use a colon, and you can actually pass in the variable. So we'll say false. Do disable collider false. So it's a little more code that you're writing, but at a glance you can be like, the parameter show is set to false, do disable collider is set to false. Yes. Especially if you've ever worked with Facebook's API. Oh my god, because everything's a string. It's just a bunch of nulls. You're like, wait, what is this null?
The other thing that is really useful that's not likely to be in this application that I work with the most is adding in a database. Because you want a high score, right?
Right.
You have to have a database to have a high score.
Exactly.
The database, your services layer that you're going to build inside of your Unity application is going to have at least 50 methods. All those methods are going to have 80 different parameters for God knows why. It's very, very useful.
So it's very useful. And again, because chances are, if you're working with somebody else, again, just because as you saw, just looking at it, it's just false. Like what is that? But here you can look at it, show false, do disable collider false. Okay, cool. And to make it even a step further, what you should be doing is documenting your code by adding comments. So since we're on this topic, let's go to the mole on this show, for example. And what's really nice about Visual Studios is if you do a triple /, you get that, right? A quick summary of what this method does. So you can say this method either shows or hides the mole. It will trigger the animator to play specific animation states. So this also lets you know that, hey, this method is going to interact with the animator component. And here on the parameter show, you can say if true shows plays the show animation, else plays the hide animation, right? And on do disable collider, if true disables the collider, else disables the collider. Cool. Now if we go back to the game manager, if we hover over this the method here, it actually gives us this, right? And if we hover over every single parameter here, like the show, it even gives you a little detail of what you put in here. So you can see here it says if true plays the show animation, else plays the hide animation. If we hover over here, same thing. So this way, if you're building something that's getting pretty complicated, you want to document your code, because chances are if you come back in a month, you may not remember why you did certain things, right? And this happens a lot. Like even if you're working on the same project, you're the only developer, you've written like all this code, and you started working on a separate piece, and you come back, I need to update something. You go back, you're like, wait, why was I doing this? Or how do I? And you're the one who's working on your own code, and you don't even know what you're doing. So how do you expect somebody else to know what you're trying to do? So document your code as much as possible. Okay. Oh yeah, trust me. So yeah, document your code. It saves lives. All right. Cool. So we have this monitor mole. Okay. Now one thing we need to do is when we actually show the mole, okay, once we're ready to show the mole, we need to monitor it, right? Because at this point we want to show the mole, right? So now we need to monitor it. So let's say this dot start coroutine. And the reason why I'm actually starting this coroutine with a string is because in order to stop a coroutine in Unity, you need a string. You need to have started it with a string, like how I'm doing it here, in order for you to stop it, because you can only stop it with a string, or if you get a reference to the actual coroutine object. I don't want to flood my script here with more fields. So for now, because this is very, very simple, we'll just do this. But if you wanted to start and stop a coroutine that took in more than one parameter, you're going to have to start like holding references to these coroutines in order for you to be able to start and stop them. So to know more, you can just look at the Unity documentation. But for now, let's just do it with the string. So we need to monitor it. As soon as we have the mole pop up, let's begin monitoring. So after 2 seconds, it'll hide, right? Cool. But what happens if we tap on the mole, right? Within those 2 seconds, we need to stop the monitoring logic, right? And so we need to do that. So on the mole got whacked, let's do it inside the reset mole. So we're going to say this dot stop coroutine, and we're going to pass in a string. So let me fix the bottom one. Monitor mole. This way, after you actually click on the mole, we stop the monitor. Because there's no need to continue monitoring it, right? Because we already hit it. Okay. So let's see what happens now. So one thing's going to break, but let's see what happens. And let's see why. Okay. Okay. So our mole's going to pop up. We're going to hit it. And that's cool. But what happens if we wait too long? So it worked. It hit itself, right? The monitor did its job. It waited 2 seconds, and then you reset the mole's position, but now, or it hit it, but now we're stuck, right? The mole's not popping back up. Why? Well, there's a breakage in our loop. We need to, basically when you're creating a game like this, you need to have a circular game loop. We went to a flow, if you think of it like a state machine, we went to a node that went dead. It didn't go anywhere. We need to link it back in. How do we do this? Okay, well, the problem is here. We say hide yourself, and that's great. The problem is there's no way to know when the animation is done to let the game manager know, hey, it's hidden now, and do something. So there's none of that. Yeah. So should we do something? How do we do this? Or what's the solution? Should we wait for a while, or what should we do? Wait for the animation time. It's a great idea. The problem is, and the problem with a lot of developers is, we have no idea how to do that. There is a way, but it's very weird and it's not foolproof. And the reason why is because, so if you look at animation state, right, the way the animation state works via code is it has this thing called normalized time. So it's a float value. So it starts to 0 and it just keeps going, right? Every time the animation loops, right, it'll start from 0, it'll go up to 1, then it becomes 1 point something. The point whatever is actually the progress of that animation state. So it's going to go from 0 to 1 to 2 to 3 to 4, and everything in between is the actual progress, right? Between the two integers, that middle part is the progress of the animation. So there's no way for us to capture like, okay, it's done now. It's like, it's done, but it's going to keep going because it's going to start up again. And all we know, the only thing we can track is how many times the animation has looped. So that's a problem. There's a solution, though. It's using event triggers or animation triggers. So when animation is done, for example, the hide, we can actually call a method, right? Is this the best way? Well, we'll see. But I want to also show you how you can use animation triggers, right? This is very well known in fighting games, right? When a particular frame happens, something happens, right? It's like, there's no wait timers like, oh, wait time. No, it's based off frames, right? So on the 3rd frame, something happens, like the hitbox on the foot activates. So now when it hits something, you get hit. That's why if you're like a lot of those pro, fighting game players, they'll know, it's on the 4th frame the hitbox enables, and so if you can like dodge that on the 4th frame of the animation, you can dodge it, or you can do a counter attack or something like that, right? It's frame based. If we do a timer, it's variable. We have no idea what frame it's going to play on. So we use frames, however, much better. So let's try that. So let's go to Unity. And here's our animation window. We need to click on the mole, okay? Because our mole has our animator component, and we have our animations right here. So the one we actually care about is the hide. So let's go to the hide. And we only care what? We care when the animation of the hide is complete. So about right here, right? These are all the keyframes. So we want to go to here. So when the mole is fully hidden, right? So how do we add an animation trigger to this particular frame? It's this little button right here. So it says add event. Just click on it. Bam, that's it. So now at this particular frame, when this frame happens, this event will get triggered. Okay? And we can move it. We can actually click on it. If we decide later on, oh, we need to move this, we can move the trigger around. For now, we're going to put it to the end. And you can see this animation event has this function. These functions is everything that that's public, okay, and that our mole script has. So it's not just the mole script; it's actually any script, okay. So let's make a function here that'll let us know that, hey, this mole is fully hidden. Okay. So we'll say public void on animation. We'll just call it hide. So we know, hey, this is an event animation event, particularly on the hide animation, right? So there's a strong dependency going on here. Do something, right? So let's go back to Unity. Let's click on our animation trigger here. And there it is, on animation underscore hide, what I just created. So let's select that. So now, when it's fully hidden, this event will trigger that particular method. So now we can, in our animations, we can actually trigger events on our scripts. So that's pretty cool. Okay. So now what do we want to do? Well, because we're actually tying our gameplay to the actual animations, one thing we can do is we can create an event, right, that we can actually raise when the animation is complete, for example. So we can say, create another event. On hidden, just like that. So when a thing is completely hidden. Okay. So when that happens, we're going to use the question mark for the null checking. So on hidden question mark dot invoke, just like that. So if anybody subscribed to the hidden method, we will go ahead and just begin the alert. So in Game Manager, we need to figure out a way, where's the best place for us to hook this in here? Okay. So we'll do this on the monitor, right? So we'll say this.mole dot on hidden plus equals, let's create a method stub here, okay? So we'll do this here, right? So after we call show false, so it hides it, let's basically say, hey, let me know when you're done animating, right? When that happens, right, we need to make sure that we unsubscribe, because remember, when they get whacked, it's going to hide as well. But we don't want to know when that happens, because we don't really care, because that's a good thing, right? The user actually interacted. We want to know when they don't. So we need to make sure that here immediately we unsubscribe. Right? So that it doesn't happen again. And then we're just going to say this.start coroutine reset the mole. Right? Because remember, what's going to happen is that it's going to wait half a second and then move the mole. Right? When we show the mole, it's going to pick a random location to position it. It'll actually move it to that location, and then it'll start the monitor. And now we are linked back to our game loop. Right? So if you were to write a state machine of this, it's now fully circular. So it'll just keep going on forever. And that's kind of what we want. So if we go back to here, if we hit play, right? If I don't do anything, right, so the mole's going to pop up, and after 2 seconds it should hide, and it should pop up again. Right? Isn't that how whack-a-mole plays? So if you weren't doing anything, this is what would happen, right? Now, when you after the 2 seconds, what would you want to do? Well, how Kelly was saying that, sometimes maybe it's after 3 times, if you don't hit the mole on time, then the game's over. So that can be our quote-unquote lives. So in that little method, we now know when that particular event happens, and we have a particular method for that. So you can do something like that. You can do lives and then have a check to see, okay, how many lives do you have? Oh, you're 0, game over. Right? Or we just do like this, where it just keeps going forever, and then you have a timer, and it's like after 30 seconds, game over. Either one works. Right? The 30 seconds, obviously, you'll have a match. That's a fixed time length, which is 30 seconds. Or you have the one where it's lives, and the amount of time that's going to go is, well, variable. Somebody can be really good at the game and just keep going on forever and ever and ever and ever. Right? Just like here. So you see? The mole pops up, I click on it, bam. See? Or I just don't do anything, and it'll disappear after a while because of the monitor. It's monitoring it, and after a couple seconds or whatever, it hides it. And you get no points. That's the important part. You don't get points. And the monitor went to sleep, and I woke it up. All right, cool. Does that make sense? All right. So let's build this again. Make another build, and let's check it out on the device. So hit Control B, and we'll do another build. And I'm just going to test it on my phone. Hey, Mike, is there a way to stream the screen of the Android device to, let's say, your computer? I know you can record using ADB, and you can record, but I don't know if you can stream. Yeah.
There's a program that I can send you.
Okay, perfect.
Super well free.
Nice. Free is always good.
And open source.
And even better.
Right, and free.
That way, because we're going to be doing a lot of builds, and we want to be able to test, to make sure. All right, here we go. So there's the game on my device. So, in the video you can't actually see it, but as you can see, after 2 seconds, it's going to disappear, and it's going to keep going. If I tap on it preemptively before the 2 seconds, there it goes, and it's actually pretty fun. Actually, I'm not gonna lie. Okay, well, there's the demo, right? So that's pretty good, right? So some progress. That's some pretty good progress right there, yeah? Okay. Nice. Is it easy to set up? Maybe I can do it because we still have half an hour. Maybe I can set it up right now.
Yeah, you can probably set it up pretty easily. They actually made it a lot easier. Sure. I tried like a bunch of screen sharing, and none of them work except for this. Either it works well, and then you have to pay like $30 a month, or so if you scroll down, there's get the app for this. Do you want to do 164?
Right, so this one is, yeah, perfect. Oh wow, so I just call this command and that's it? I still don't have to download an app on the phone?
Because it uses ADB.
Beautiful. Very beautiful.
App-based solutions are just terrible.
Yeah.
They also have it built into Android Studio, and then they did everyone, so you're going to want to extract these.
Oh, yeah. Let's see here. Extract all. Extract. Is there an installer or just?
You should just be able to open it.
Oh, okay. So let me
You just double tap it. It should work theoretically.
CMD. Oh. Hey. Oh. Password. Hold on. But dude, that was nice.
Yeah.
Epic. Whoa. All right. So, where's my whack-a-mole? Whack-a-mole. There it is. Perf, dude. Very nice. All right. So that's our game. There it is. So that's how it's working on the device. So you can tap on it. As you tap on it, it'll go away. And if you don't, it waits 2 seconds, and after 2 seconds, it goes away. So that's the basic game. Dude, this is a game changer. Nice. Very nice. Okay. Wow, that took like not even like 5 minutes. Very cool. Nice. I am really happy about that, actually. See, everybody needs a Corbin in their life. I'm telling you. Everybody needs a Corbin in their life.
No one says that, but I need a Corbin. I need my brain to work. It's really the big problem.
Awesome. Cool. So the next question is, okay, so if you're a Sac State student or not even that, like, oh, I want this game to run on my website or something like that. Well, that's the power of Unity, is we can also actually do a WebGL build. And if you're a Sac State student, I can also show you how you can throw it up onto Athena, right? I think so. During the winter, me and my friends, we did a Secret Santa. And I made a WebGL game so they could actually register. So I don't think it's up anymore. And oh, okay, it's still up there. But I know that the backend is broken because I disabled it, so it's going to give you just a bunch of errors. But it's hosted on Athena, and there it goes. Right? And there it goes, and that was our Secret Santa thing. So you can actually go here to like log in, and you can actually type in the thing. So this actually won't work. It's going to have this thing, but my backend is actually turned off. And so yeah, a little satisfying. So I had this thing where I had like, oh, you're registered, and then so pretty cool. And I what's that? Turn up the volume? Unknown error, finally. Yeah, what's really cool about this is I actually have the beats of the music tied to the trees, so the trees are actually animated. This is all using a spectrum analyzer to get like the different spectrum bands, and I'm just like animating it. So this is all in real time. Yeah, I try. So, yeah, it was a fun experience. So yeah, and I have this running on our Athena, so that's like my little website thingy-majiggy that I was like working on. But yeah, so this is hosted on Athena. So how can we get this up onto Athena? So you guys can show your friends, or when you're in class, you can, instead of paying attention, you go play whack-a-mole, right? You can put your little games up there. No, this is actually really good because, if you're doing an interview for a job or something like that, you're like, I want to show this game. It's on my laptop, and I bring it. You're a student. Athena's free. Just throw it up on Athena. Why not? Make sure it works first before it's your possible employer. But yeah, you can use WebGL. As you can see, there's a perfect example of me just, building something, having fun, and maybe going a bit over the top. But hey, it worked. Right? So how do we do that? You go to Build Settings. I'm not sure if I have WebGL installed on this. I do not have WebGL installed on this particular version of Unity. But if you want to install it, you go to the Unity Hub, right? Because chances are when you downloaded this, you weren't thinking about WebGL. If you go to your installs, I'm using, what version am I using for this one? 4.13. If you go to the three little dots here, you can go to Add Modules. So here you can add and remove modules as you want. And so here are all the modules that are available to you. And there are also some modules that aren't listed on here. For example, Xbox, PlayStation, those aren't actually listed on here because you need to get a SDK, Unity SDK, through them, right? So if you want to do Xbox stuff, yeah, you wouldn't add it through here. You would get like a special installer package, and then it'll install the Xbox modules or whatever. Actually, you might be able to actually use the Universal Windows Platform EXE because technically an Xbox game runs on Windows because they're using this UWP format. So technically everything that's on Windows Store also works on Xbox and vice versa with some modifications, right? Anyways, yeah, so you can click on WebGL, and we have sometimes fast internet here. So I'll hit done and say yes, and then it's going to install the WebGL support. It's about 800 megabytes. Or is it on this one? Yeah, it's going to install it on this one. I installed it on this one, which is a newer version, which just came out today. Which is funny because on my Mac I installed 0.16, and then today they released 0.17. So I'm like, great. So, whatever. So our internet's actually pretty fast. So it's actually downloading, but we may not be able to get to it. We have 20 minutes, and so maybe we do it. But I know most of you guys are on Windows, and only a few of us superior people are on a Linux machine. Because I have a make file. Because the way I was able to do the Secret Santa WebGL build to put up to Athena is I used the make file. How much do you want to bet? Because I tried that. Right? There's nmake, but nmake doesn't work anymore. But I have to download a thingy-majiggy.
Well, yeah, but you have to download.
Yeah, I want it. I know, but it's just like.
Plus, you could use Windows subset for Linux now. So.
Yeah, it's POSIX. You could do it, but because today I was trying to write a Java little jar file for everybody, so they can just run the jar and basically do what make was supposed to do. But I decided to go eat Greek food, so I didn't have time to do that. But anyways, the reason why is because I want there to be a uniform way for everybody to be able to do these uploads to Athena particularly. So I'll have something like that. I mean, I have a make file where on my Mac, after I did some modifications, all I had to do was build a WebGL project. I ran my little make file, and it would upload it for me. I had to type in my password and stuff, but it would do it for me. Because there's about 6 different commands that you need to do in order to get all this stuff to work. Just particularly because on Athena, as soon as you put any kind of file or folder into the HTML folder, it does not grant access to the world. And we want to be able to access these files from anywhere, right? The internet. So permission issues. But my little make file fixes that. So if you know a safe link, Corbin, to enable make, because I know there's nmake with Visual Studio Tools, but it's not in 2019, and that's what I was trying to use.
I would honestly recommend using
GNU make. Oh, Windows subscription links. Okay. All right.
Just because like you can do anything in Windows in the command shell if you hate yourself enough.
I was trying to use PowerShell, and I started like, you know what? Nah.
Well, and PowerShell.
It's okay.
runs into a lot of the same issues.
Yeah.
That like command prompt.
Yeah.
You can technically install all of new utilities directly to your command prompt. You'll regret it, but you can do it.
So anyways, I'll have something to do the, so I've downloaded WebGL. It doesn't pop up here, but that's because we need to restart Unity. So I'll just close this, and I will open up the hub again. Install, oh, no, there. Just open up the project again. And we should have WebGL stuff. In fact, I will, when I go home, I will upload the whack-a-mole, what we have so far, up to Athena, and I'll link it on the Discord, and you guys can go ahead and just like see it, you know, working. You know, so I'm not bluffing. It's really easy to get it working, right? Which is perfect because all these little projects you're going to be doing Unity, especially something like this, you want to have some way to start building your portfolio and have easy access to it. And what better way than to use Athena, right? That's why it's there for you guys to use, you know. So, you know, take advantage and use it. So file, build settings. Here's a WebGL. And so you need to switch the platform. So we're going to hit switch platform. And it has to obviously switch over. And so this can take some time. Okay. And we get a bunch of errors. And that's fine. Cool. Just ignore those. All right. Go to player settings now. We have this all new player settings for WebGL specifically. Okay. All right. So we just need to make sure that. So here, if you want to control the size of the window, you would do it here. Right? Because the WebGL is just it's just like a frame, like a div, and you can just stick it in there, right? However you want, and just be like, hey, just, you know, make it this big or whatever. In fact, when you actually build it, it's going to generate all the HTML code and the CSS and whatever JavaScript is required, and you can just modify it to your heart's content. So as you saw on the Athena one, it said WebGL, like it had that little border on it that said WebGL. You can actually remove that. You can do whatever you want, right? Like a lot of these games that you see on, what's it called, Congregate, they're WebGL games from Unity, and you don't see any of that stuff. Why? Because they just strip it out, right? That's just all just, you know, so you have something to look at. So let's make a build. And again, every time we make a build for a particular platform, you should always have a builds folder and then separate them based off platforms. I'm going to create a new folder called WebGL. So that's how you're supposed to do it.
I always just exported and then like went through the painstaking process of finding wherever.
No, I like to create folders.
A lot smarter.
Yeah, Android, WebGL, have one for OS X, whatever I need. So new folder, and right there, boom, and it'll just start building to it. And it's going to build it into a folder. Because that folder, technically, you're supposed to throw that up onto your web, whatever, you know. That file is going to contain the HTML, your JavaScript, any CSS, and all your core logic of your game, right? Now, this whole WebGL stuff, this is using, you know, HTML5 technology, right? This is just putting it all together, and it's basically everybody is in agreement that, you know, this is going to be a graphically intensive applet. So I think like on Chrome, you need to enable WebGL support. I know when I was testing this on my my Mac, I had 2 on Chrome. Firefox is fine. So yeah, for some reason, if you try and run the maybe it's different on Windows, I'm not sure. But I know on my Mac, when I was trying to run the WebGL game, like locally, it would not run. It kept getting blocked until I threw it up on Athena. Then it ran. I was like, okay.
So it's not an issue with WebGL being enabled. It's an issue with security. It won't run any form of like native quote unquote code from a local environment. And there's ways around that for local development.
Oh yeah. I saw a lot of blogs on it, and it was kind of like, I just, I was just trying to get rapid development. That's why I created the make. So it was faster for me just to say make and then just throw it up on Athena, and then I can just test it from there. Which
You have to host an HTTPS and probably have like SSL.
Oh, I don't want to.
Yeah,
I don't
that's
do
my
that.
reaction to. Oh.
Actually, it might be easier if you just like have if you have like what's it called examp, and you start it up and throw it inside the HT docs. Just.
You could also use like ngrok, something like that.
Oh, okay.
There's a few different ones.
Yeah. So WebGL requires IL to CPP. So IL to CPP means intermediate language to C++. And so when you're building with IL to CPP, the first build is usually the slowest. After that, it's a lot faster. And it's mostly because IL to CPP will create scripting symbols, and it'll put them into a zipped file for you. And it's pretty massive. But after that, every build after this will be much, much faster than this. So if you're building and it's using IL to CPP, just know that every build after the first one will be a lot faster. A thing to note is that if you're making an Android game or app or anything like that, from my understanding on the Android documentation for the Android developer, is that you need to have Android 9 and above, and it has to be 64-bit compliant. So all new apps have to be 64-bit. Like, you don't have a choice in order for you to submit to the Google Play Store. And in order to get a 64-bit Android application, you need to use IL to CPP, which means you need the NDK. So the next time, I'll show you guys how to download the Android NDK. So the NDK stands for Native Development Kit for Android. And Unity has a special version that you have to use. You can't just download any NDK from the SDK manager. So we'll download our special NDK for Unity to work with Android. And it will be 64-bit. And again, it has to run through this build process, which is IL to CPP. And it'll give you an x64 build of your APK. So there's a lot of acronyms there. But anyways, yeah. So that's something you have to do. So no more 32-bit support on Android, which is a good thing, right? That's called progress, right? So throw away 32-bit, only 64. So we have 10 minutes before we got to get out. So hopefully this build happens before that. And then, the other thing is I need to zip it up, throw it up to Athena, and I got to change all the permissions. Great. Yeah. But there is a way. There is a way to do it recursively. So, yeah. Does anybody have any questions? No? Pretty exciting? Yeah, whack-a-mole? It's pretty nice.
I love the intonation you use there.
Yeah.
Please find this exciting.
Please find this exciting, please.
I can identify with this strongly.
I don't know. I think this is cool. I think it's peak cool. Thank you. No, you're pretty cute. You're all pretty cute. Keanu Reeves. Right? So the worst thing that happens is it's in this like little build part right here, this progress, and then it says error. So hopefully we don't get that. But I've had that happen. So yeah. I'm actually surprised I still have a full head of hair with all these kinds of issues that I've had. Right? Well, there's a meme, right, on developers where, I think I said this before, whereas like the boss guy, he's like, there's these two developers on their chairs and they're like hitting each other with sticks and the boss is like poking his head. what are you guys doing? Get back to work. And then they're just like, we're compiling. It's like, okay, no worries or whatever. Because it's true. When we're compiling, like, what do you want me to do? At this point, yeah, you're right. Go get a cup of coffee and then come back or something like that. If your projects are massive, like literally massive, build times could be in the hours. That's why you need to have a really fast CPU. Because when you're doing these builds, it's all CPU. You might be able to offload some things on the GPU, maybe. I don't know. But I'm pretty sure this is all, yeah, this is all CPU stuff. So, yeah. And I have 16 gigs of RAM, but the problem is that my CPU is a dual core. It's an i7. It's on a laptop. The fans are spinning. I'm recording the screen. I'm also streaming the screen to this computer to put it up on the projector. So, yeah. What's the usage? What's it called on Windows? Task Manager. I was going to put Activity Manager, but I'm like, I'm not on Mac. Okay. Activity Manager. What's my CPU usage like? Okay, it's all of it. Yeah. Yeah. So there you go. Anti-malware.
Yay, anti-malware executable service. It's not
What?
you can't do anything with it. You can't do anything with it.
Stop.
You have to go into settings.
Oh my God.
Hooray. And it's going to scan every new file that you build as you're building.
Oh, wait, is there a way to turn that off?
Yeah, yes, there is.
How do you- Huh? Settings? Settings? Yeah. And where do I go? Maybe security? Wait, what'd you say? Windows security? Oh. Oh. Manage settings. Real-time protection. So I just turn all these off? Bam. Yes. Die. I don't know what any of this stuff is. And I don't really care right now. Or not, excuse me, Task Manager. I don't use this to surf the web that much. I just use it for, what the heck is Feedback Hub now? All right, wow, that's a lot better. Whoa, look at that. Nice. Well, that's a lot better. Cool, thank you for saving my computer. Oh, the metal here, the aluminum, it's pretty hot. Yeah. All right. Well, I don't think it's gonna happen in time, so I think I'm gonna hit cancel. I'll just build it at home or something like that. And I'll throw it up on Athena. So I'll make sure I throw this up on Athena. And yeah. So does anybody have any questions? So we can wrap this up. No? So is it almost done or what? Oh, compiling WebAssembly. Okay, this should be fast. Well, should, yeah. Let's 5, 4, 3, 2, 1. Oh, okay, we'll just leave it. Whatever. Yeah.
I remember one time I compiled Chrome. It was like an hour-long ordeal with like 8 cores.
Yeah. Telling you, it's time-consuming doing these builds.
It's short.
Yeah. I compiled what's it called, WX widgets for Mac from source. That took about 45 minutes.
And what sucks is that like you'll get to the very end and the third to last step it'll fail. And you're like, not only am I failing at the very end, but I don't know if the future stuff is gonna fail. How do I fix this? Oh god.
With the WX widgets, if because you have to build it with certain flags.
Oh, I didn't mean that one in particular. I just meant like
Yeah.
any sufficiently large project
No, yeah.
going to fail.
No, it'll build, and then when you try to run it, it'd be like, oh, I don't have these flags enabled, so I can't do anything. It's like, oh, great, I have to sit another 45 minutes, enable all these flags, and then run it. It's like, oh, geez. So no, I understand fully. WX widgets is pretty nice, though. I think it's not many people talk about it. It's a nice way to build C++ GUIs without having to use what's that one, Qt by Nokia, or no longer Nokia, I think.
The what?
No, Qt?
Oh yeah, Qt. Actually, I think it's its own thing now.
Is it? Yeah, because it used to be owned by Nokia, but I don't know.
It spun off to its own thing.
Nice.
We do not want Microsoft and Qt.
Qt. Well, they have Windows forms. Yeah. I actually really like Xamarin. I wish there was a Xamarin for like. I think there is a Xamarin for like to make Mac stuff. Yeah, but yeah. Okay. Actually, why am I even waiting? Because even after this, it's not gonna run in Chrome. It's gonna get blocked. So I don't even know why I'm waiting here. I'm pretty sure it's gonna get blocked. As soon as I try to run, it's gonna get blocked. And if I throw it up on Athena, I still need to switch all the permissions on every single file. And I have to look up the command real quick to do that. It's a simple find and exec. All right, one more minute. I don't think it's gonna happen. Like how Corbin said, it's a permission problem. Yeah, I mean, because a browser will just do anything you tell it to do. It's kind of a security risk. So, you know, if it comes from the web, right, we kind of hope that you know what site you're going on to. Versus like if you download something, I think it's mainly because you want to, you know, make sure that none of your cookies get taken or anything like that. You know, those are pretty valuable. So, I think this is stuck.
So it's twice as complicated as Google Chrome.
I mean, Google has something like, Google's still using their monolith code.
Yeah.
So one Git repository for like billions of lines of code, something absurd like that. I would not want to be on their
All right, it's 5 o'clock. I'm gonna call it. I'm calling it. Oh, compressing build results. Oh. Woo! Yeah. All right. And here is our index. This is what we want. So actually, we can go ahead and open this just really quickly with the notepad. Oh, VS Code. That's better. All right, open it with VS Code. There you go. See, it's just plain old HTML. This one. But this is the actual right here. So this will begin the actual Unity loader to actually load up the game, and all of our game is inside of. If you go back to here, it's inside here. Our actual game, our actual WebGL game it's inside here, right? Unfortunately, I'm pretty sure if I try to open this, it's not going to work. But hey, let's try it. Open up with Firefox. Sure. And it's not going to work. Yeah, it seems it does not support running Unity content, blah, blah. So he says, please upload it to an HTTP server or try a different browser. See? So it's blocked. All right, so nothing we can do.
You can install packages using npm called HTTPS. Ah,
yeah, same like example and just throw it up in the HT docs. Yeah, So we can't do that, but I will throw this up onto Athena as we have a WebGL build now, and this should work. Okay. Nice. Also, because we can use WebGL to throw things up on Athena, we can also have multiplayer. So we can use multiplayer WebGL and connect. You know, if you have a game, you know, it can be inside of a, you know, like how we're inside here, this lab, and then connect, you know, your WebGL games using multiplayer and play like tic-tac-toe together or play whack-a-mole. I don't know how that works, but you know, do a lot of things. Okay. Yeah. 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 Who gets the most points, right? Yeah, we could do that. Yeah, actually, we could do that. Game designer right here in the make. All right, cool. So we'll call time, I guess, on that, and then I'll make sure to actually I'll do it right now so I don't forget. What is this? Node.js. Oh, okay, yeah, go for it. So go here, documents, development, SoDA, whack-a-mole, bash here. So these are all the things that we changed today. So, and I closed Unity. Yes, I did. All right, cool. Cool. What's today's date? 11/2/11 SoDA meeting. Cool. So this code is now uploaded. So if you guys want to take a whack at it, you guys can go ahead and do that. Cool. Take a whack at it. Yeah. Oh, did I not save everything? Oh yeah. We'll just close. Cool. Awesome. Cool. Well, thank you guys for coming, and I'll see you guys on Thursday.